Good morning, guys. Hope everybody's doing okay in the great state of Hawaii. Uh, I'm sorry that I have to record this session. I know that the plan was that I will actually do it live and I will interact with you. I would love nothing more than that, but unfortunately, I have some personal matter that I need to attend on the 8th. So I just thought that it would be good if I create this video for you so you can watch it at your convenience. Uh, of course, last time I saw you about 4 weeks ago, we went through the secure coding, some principles. I have another lesson for you. We will kind of, I want to touch on some of the things that we talked about last time. And then I would like to introduce some new concept, especially as they relate to privacy. So, this will be probably around hour, maybe a little over hour session for you that will hopefully give you some better understanding, not only how to code securely, right? Because you all want to be a software developers or you are software developers and that's your project, but also so you understand that with the great power kind of comes the great responsibility, right? Not to quote the Peter Parker here and the Superman, but it is indeed a true that as you start collecting the data that the users are providing you with as they interact with your applications that you are developing, you really need to start thinking about what it actually means, right? What responsibilities you have uh, as a custodians, at least of the data that the uh, customers are providing for you, and also what harms, right, can the data actually cause the to the users. It's kind of a gray area for a lot of people. Big tech companies they have kind of love-hate relationship with that, right? But I really believe in that the body of research clearly shows that there needs to be some accountability about not only about what you do with the data, but how you collect it, what you actually share with your customers about the purpose for collecting the data and so forth, so on. So we will talk about it today. So let me share the little interactive that I generate here. Let me move these things around as always for the Zoom. I have some idea what's going on here. So I just create, you can see about 19 page or slide interactive over here. Uh, Very similar to what we did last time when I saw you a couple of weeks ago. Uh, so, once again, you are a software developers, right? I understand that, your uh, first and foremost instinct, I would say, is to actually deliver app that is working, right? Functionality, of course, trumps almost anything in this game, right? If the app doesn't work, then what's the point? Completely understandable, right? Everybody is on the same page about the main purpose of software developing. Now, I would argue though that as a software developers, you have a unique opportunity to actually introduce security, right? And really uh, highlight how you will protect the customer's data. And that's something that may give you a competitive advantage, actually, right? Because you can, say that, hey, unlike the other people, I am actually thinking about what it means. I appreciate the opportunity to serve you. I want to make money, of course. I want to serve the customers, but I also want to do that safely and ethically, right? So not to, treat the customers as a cash cows that you can, just collect the data and then sell them nilly-willy to everybody who has a little bit of money here. Right? So today, really, after you start developing your app, or really just thinking even before you start developing, but as you start thinking about your app and what the app should do from the functionality standpoint, I really want you to start thinking about the security implications and the privacy implications of your apps. Right? Remember, the application security, right, is not just for the security experts. The old paradigm that we will kind of sprinkle on the security after the development has been done and everything is functioning properly, it's not going to cut it anymore, right? It's been kind of on its way out. Now the AI, of course, kind of flipped the paradigm, right? The AI can actually spot the security gaps much faster. It can exploit them much faster. So really, once again, you are in kind of unique place as you are developing your applications from the scratch. You really need to start thinking about security as a central piece of your application. And then, the functionality kind of wraps around the security, the security posture and the message that you want to have for your customers. And that's real important, at least in my mind. And I think that the customers, they really are looking for that leadership from the software developers, so they know that they can trust the product that you will eventually put out there. We talked about the CIA triad last time that I delivered the lesson for you. Confidentiality, integrity, availability, all of those needs to be addressed in your planning stages. When you are thinking about what your app should or shouldn't do, this is really the core principles of the secure coding, right? And we talked about it. These pillars, they are mutually exclusive, right? There is that, pull and push relationship between them. The more confidential I make it, right, the less available it really becomes. If I put a lot of emphasis on integrity, then both the confidentiality and availability kind of goes down, right? So it's this inverse relationship between all of them. You have to find the right intersections, but all of the three pillars need to be considered. You cannot really say that, hey, I am only interested and I will only address confidentiality over here, right? Because then you can develop real strong encryption algorithm, but guess what? People that don't have computing power to actually run those strong encryption algorithms, they will have no availability to your system, and vice versa, right? You can say that, hey, this will, people can run this application from the mobile devices, maybe from IoTs, from watches and all of the IoTs that exist now out there. But because they don't have the computing power, then now I need to actually use less secure algorithms, so the confidentiality will suffer. So you can see how, the decision itself will have to be made about what is the most important thing and when you will put the emphasis from those three pillars, right? One is usually the main, right, concern. You want to really protect data, then confidentiality will be your main concern, and then you need to find, how much availability you need, and you need to find that equilibrium and the confidentiality and availability meets, right, with the integrity. So all of them will come into it. If you remember, we have the emails over here. So you can actually come here and we have a nice little Macomber cube, right, that actually shows that three-dimensional relationship between all of them, right? You have the security over here, you have the informational states, you have the measures, confidentiality, integrity, availability over here. So when I split it, I can say that, hey, I have a confidentiality, which is preventing the disclosure over here, right? Integrity. So how do you protect it from modification, right? I really like to think about integrity as trust. How do I trust that the data is actually correct here, right? And then availability, and availability, of course, it's that, hey, the users that needs the access have the access when they need it. People who shouldn't have access shouldn't gain the access under any circumstances, right? So that's pretty straightforward over here. Now that, of course, is not happening in the vacuum, right? You are talking about the data that are either processed, right? So you are in some way, shape, or form manipulating them. You are computing some values off of the data, right? They can be in storage, so they can be sitting on the USBs, they can hard drive and SSDs and server wherever, right? Or they can be in transmission. Of course, they may be somewhere on the network, right? They may be traversing the network from your laptop to the server, right? Or from the data center to your customer's phone if they run the application on their phone, right? And then you have the uh, technical countermeasures, right? The controls, if you will. You can develop some policies and procedures, right? So administrative controls, if you will. And that's the big overview, 30,000 feet overview of the security measures, right? It essentially is a promise that your stakeholders, both internal and external, so customers, right? You are telling the customers what you actually want to do and how you will do it to protect their data. It's promised to internal customers, your IT team, your employees, to give them the know-how about what is actually expected of them to protect the information that the customers trust you with. Then the technology, of course, and that's where most of you will live, right? You are software developers. You have to find the technical solution to actually either software or hardware technical solutions that will protect the data, right? That will make your application more secure. And then, of course, the awareness training and education, right? Security policy. We have to train both the, once again, external and internal stakeholders. External stakeholders, you will give them a privacy policy, right? That's part of your application. So the users know that, hey, if I will fill this form and engage with your applications, this is what I can expect will happen with my data. That's how they will be stored. This is how they will be encrypted. This is who will have access to it, right? They are now aware of some of the risks that exist, right? And once again, internally, the same thing, right? You need to provide your employees with the information and know-how about how do you expect them to actually protect the data and the infrastructure. What we will do, right? What will be the procedure of storing information, processing them, who will have a view, right? Who can, read and who can read and modify the data. All of that needs to be specified. All of that needs to be clearly stated in the policies. And then, of course, the last thing is how they will all interact, right? So you have the confidentiality, integrity, availability, then you have the processing, storage, and transmission. So all of them, and you have some good examples. So over here, VPNs, right? If I will do a confidentiality in transmission and the control is awareness training and education over here, how does it look in a real world, right? Well, we can have a confidentiality transmission awareness training education. We will actually have a training or some professional development for our employees that will tell them, hey, we want to keep this data confidential because they are maybe PIIs, PHIs, whatever type of data you have that you need to keep confidential, right? They are in transmit, right? So we need to protect them as they are traversing the network. We cannot send them as a clear text over here, right? And of course, the control is awareness training and education. So the PD or poster or whatever it may be that actually reminds them, explains to them what we want to do is appropriate over here, right? For the integrity, I can go over here to integrity, so trusting the data, right? And let's do a storage, so we do something different, or let's do processing here since it's already open. Integrity, so processing, right? And technology, so how do I actually make sure that the social security numbers are correct, right? How do I trust it? Well, there is an integrated processing technology, right? I can actually run it. I can uh, hash every single social security number when I'm getting it, right? Uh, from the standpoint of our user input, I can actually set up masks that will, you know, check if the number is 9-digit number, right? Because that's how many numbers is in a social security. So if someone inputs 10 or 6, right, it will just tell them, hey, I don't think that this is correct, and then I hash it, I store it, right? And every single time when I want to use it, I hash it again and I compare the two hashes, right? If they are the same, then I know that nothing got changed, right? This is the correct information. If the hash is different, of course, then you know that you have a problem. And the last one, availability and policies and procedures, right? So availability of storage policy and procedure. So what will be the policy that establish the user access rules for file storage in the cloud, right? How are we going to go about it? So you have to have a clear idea about what you actually want to do, what does it supposed to achieve, right? And you will simply write a policy and procedure about all of that. You will write up procedures for your employees so they know how to actually configure the cloud storage, the ensure the availability, right? And you will have, of course, a policy and procedure to tell your customers, how their data will be protected as you are moving it to the cloud, right? So you can see that this is actually how the CIA triangle kind of works, right? It's never a one size fits all. It's kind of fluid environment, if you will, that you need to contend with, and really during the planning phases of your applications, you need to decide, right, how these three pillars will actually coexist together. We talk about injections attacks, all kind of injections over here, right? And you can, this is a basic simulation. If you know anything about SQL, of course, this makes perfect sense, right? Most of the data are stored in some databases. Some databases are non-SQL databases, but the majority of them, of course, they are SQL. SQL is just a language that will allow you to actually run a question, if you will, against the database uh, to seek some data points into the database that you want, right? Uh, I want you to pay attention to this. If I copy this and put it into admin, right? The statement over here essentially says select all, right? So asterisk signifies all from users. So there is a table users somewhere in the database, in every single database that has a username and password, right? You have a one column that is named or one table, I'm sorry, that is that is named user. When you have a column that will have that will be a username, and one that will be a password, right? That's the match. You are essentially saying, hey, is the username and the password matching of what I have over here in my infrastructure, right? Where, of course, user equals empty over here, right? So essentially, this is a void statement, right? The user should never be empty. But or, right? And if you understand the relationships, right? So when I'm saying or, it means that either one of those can be true, right? So the user is either empty or one equals to one. Guess what? User is never empty, but one equals to one is always true, right? I mean, that's a logical statement that will always be true no matter what, right? So that, which means that if I run this, right, no matter what the input over here is, one always equals to one. And if I will say one equals to one, then I will be able to log in, right? Because this is essentially ignored. And I'm saying, hey, select everything from users where 1 equals to 1 here. If I do that, hey, welcome admin, I'm right in, right? Reason that the query became successful, right? Once again, always true, right? You have to be careful. You have to sanitize the input, right? SQL injections, they run off of the fact that software developers, right, for a lot of applications, a lot of web pages, they don't sanitize the input. They essentially allow to run the code. Now, if I will just sanitize this and process it as an input instead of a code, it will, treat it as characters, and then it will say that, hey, this user is not uh, existing in my database here, right? Very important to actually think about how you will validate and sanitize the input to prevent SQL. We talked a little bit about the cross-site scriptings over here. Uh, Once again, it's all about cleaning the input first. So the users or the attackers really in this example cannot really pass code that can then be run on the server or on the machine that actually process the information over here. If you look here, uh, if I run this code, right, it essentially says that, hey, this is just a text for bold, HTML text for bold, right? So I am bold in bold font over here. I'm bold. Now, if I will run it as a inner HTML, meaning that, hey, just take whatever the user pass and just display it, right? It will take it as a code, which this is a code. Once again, this is the beginning of the code. This is the end of the code. This is essentially what I want to input in both here, right? Or I can just save output, I can sanitize it, I can use it as characters. So it will essentially say that, hey, it will put a quotation mark in front and at the back of the statement over here, and it will say, hey, I will just treat every single character over here as a simple text, right? I will ignore the beginning and the end code. I will just display it, and you can see it right here, right? It just displays it character by character, right? When it really comes into play is the statement below over here. This code, once again, just a simple HTML statement, right? Essentially says, hey, display image, the source of the image is X, right? X doesn't exist. It can be anything, right? In this example, it doesn't exist. On error. So if the X doesn't exist, right, and now run some kind of code here, right? And you know there is it code because of course, there are the braces and the braces shows that there is something in there, right? So it's essentially, once again, you are tricking it just like you did it with the SQL injections before, right? The hacker will essentially select something that they know that doesn't exist. So, they will say that, hey, display some image from the source X, the X doesn't exist, right? The system will just process it and it will say, hey, I don't know what you mean. I have no clue what X is. So the attacker will essentially say, hey, if this makes no sense to you, right? The first part makes no sense to you, then as an error message, run this, right? Show head model. When I do that, you can see, this is actually the code that is inside of the parenthesis here, right? XSS, right? In a real world, it will probably just open the back door and start installing something on the machine, right? Once I do it, you can see that this is now showing that, hey, I don't know what the image is, right? That's the little icon over here that shows you that there should be an image that actually cannot be displayed anymore. And once again, if I will treat this with the text content, essentially turn it all into the single characters here, I will get the whole thing, right? I just escaped the whole mess because now I'm treating it as a single characters, and therefore the code essentially cannot be run on the in the application, right? Once again, very important. You have to think about it, and we talked about it before. Now, the last one from the last session, the kind of reminder that we are doing for the past 10 minutes or so, is the hashing the password, of course, right? Plain text should never be, the password should never be stored in the plain text, right? So as you do it, of course, you run it through some hashing algorithm. Hopefully you remember the hash is a one-way function, trapdoor sometimes, that's what we call it, right? This is the hash. This is how we will actually store the password on your systems, right? Which means, if you think about it, that nobody cares what this is, right? You are essentially looking for a match that this hash, what input actually creates the hash. And brute force, rainbow tables, all of those things, that's what the attackers actually use to try to figure out what the password is, right? The whole point over here is that the hash cannot be decrypted, the the password itself, right? There is no correlation between these two things as you are improving, right? And of course, that just means that now, even if the attacker gets the hash, which is this, right, they can actually put themselves as a man in the middle into as you are as the user is sending the hash to the application for the verification of the password, right? It literally means nothing to them, right? Because they will have to find the password itself, which is here. So they will have to run all the possible combinations to try to find which one actually matches the hash that they just intercept, right? Very time consuming, very uh, uh, resource intensive endeavor to do here, right? So never ever store it into plain text, always use some hashing algorithms. And of course, for you as a software developer, that means that you have to have a policy for your users, right? You have to tell them, hey, I want you to use password, right? The password should be strong, meaning at least 8 characters, upper, lowercase, plus numbers and special characters, right? That means complexity, which means that the hash will be stronger, harder to actually find the collision. So just to sum up, kind of the material that really is just a repeating of what we did last time, right? Validate and sanitize the user input over here, right? Is the email actual email, right? Is the number really number, right? Or are there some characters that you don't expect to get, and the characters can be anything, right? It's always easier to say, hey, for social security, once again, it should be X numbers, right? And everything else, if there is a upper lowercase special character, whatever is not a number, just don't accept it, right? Tell the user that, hey, there is some error with that because I'm expecting all numbers over here. Yeah. So that will allow you to strip characters that can actually run some harmful code on the back end here. Hashing the passwords, that goes without saying, right? Clear text, one of the worst things that you can do if you actually have a clear text stored anywhere on the system, or if you transmit clear text passwords between the two systems, right? It's fairly easy to actually intercept that. And, you just essentially gave someone the proverbial keys to the castle for you. And then, of course, use the HTTPS, which really should be on TLS. Now the SSL is kind of old technology, has been broken. It's better than nothing. So, if you have devices that they cannot actually run the TLS natively, then of course, SSL 3.1 is better than nothing. But really, right now, TLS at least 1.2, the version 1.2 should be uh, pretty straightforward, right? And how do you know? Well, it gives you the little lock icon on your web browser that actually shows that there is some kind of encryption as it traverses the network. Right. Once again, all of these concepts. So we talk about hashing. So if you actually go to the my emails and you go to cryptography over here, you can see how the encryption and data formatting works, right? You can actually play with it. This is the ASCII code, so this is the lowercase a. This is the binary representation of that, right? The decimal representation and the hex representation, and you can go through all of them. This is how computer actually process the information, if you will. You can practice some over here when you translate, if you will, right, from hex to the binary, the decimal, and so forth, so on. You have to be aware that there are some characters that are unprintable in every system. So that can create problems for you, and that's where the security policy and password policy actually comes into play when you tell the users what characters they can or cannot use, and you will see it a lot that the web page will say, hey, you need to do for your password, it needs to be uppercase, lowercase, number, and special characters, and they will have the allowed special characters listed over there, right? And the rest of the special characters, well, you cannot use it because their system cannot process the special characters that are unprintable over here. This is kind of the schematics of how it actually works, right, in a physical world. So it's a abstract concept. What do you actually do, right? But if you think about it, everything that happens inside of a computing is right now essentially on and off state of electricity, nothing else, right? So you can play with the switches over here. You can see that now it's on, the light is on over here, right? One is on, one is off. So A is 1, which means on, right? B is 0 because it's off, right? When 1 is on, 1 is off, the result XOR is always 1, right? If they are both ones or both zeros, it will be always 0, right? And this is essentially how modern encryption actually works these days. That will allows us to encrypt and then later decrypt the messages. Yeah, and that goes through the encryption and uh, decryption of the message. You can see that this is the XOR, right? 1 and 1, so it will be 0, of course, over here. 1 and 0 will be 1, 0 and 1 will be 1, 1 and 0, 0 and 1, so all ones, right? Now, when I will take the ciphertext here, and I will use the same key, of course, and I will go through the same process, it will give me the plain text again, right? Because it's just simple transposition of the numbers, right? 1 and 1, 0, of course, 1, 0, 1, 1 will be 0 at the end, and now you have the same, so now you successfully encrypt it, send it to someone, and if they will have the same key, they can now decrypt it, right? And then, you can just practice over here. So you have that one. There is actually in cyber, there are, if you want to see the SQL injections and how they work. Yeah. So you can essentially just go to the vending machines and you are trying to buy some snacks for your break, right? Someone else is over here. They have the data set that is connected to the web form, and now they will just try to manipulate it to give them the snack for free, right? He will go to the query, and he will essentially manipulate the query to get something for free or something else, right? So you can go through that one for the SQL, and we also have one for cross-site scripting. And the cross-site scripting is once again, pretty straightforward. How would you actually go through it? The injections, they call it injections attacks, of course, over here, and uh, it uses over here to store it to actually change the picture of the grandmother from the story here, right? So you can go through every single one of them if you need to refresh your memory and kind of get back to the speed with some of the concepts that we were talking about last time, right? So now the basics should be pretty straightforward, right? They are not. I don't think they are that hard. We talk about them twice now in a couple of weeks, so you have a little reminder. Hopefully, it's fresh in your memory. So now we need to move past that. Why is it actually important, right? What is the main reason that we want the uh, software developing, the secure coding, the actually have some kind of security, and why do we care uh, about the coding process and what happens with the data? And it all boils down to the privacy, right? So when you think about it, the security is like a lock on the file cabinet. You just lock it, and whoever has the key should be able to get it. That's the availability, right? But for the rest of the people without the key, it's essentially confidential. And since nobody has access, it's trustworthy, right? I can actually go, I can open the file cabinet if I'm the only one who has the keys, and I'm the only one who can change the numbers, then logic dictates that I can trust it, right? The privacy is all about rules about how we will actually collect the data and what will happen with the data before you put it in the cabinet, right? So how do you collect it? Who has access, right? What do you use it for, the data? And what do you do with the data when you no longer need them, right? That's kind of how we have to think about the whole data life cycle. How do I get it from the users, right? What do I use them for, right? And of course, who has access to them for the processing, right? And then at the end of the life cycle, what do I do with the data? How do I dispose of the data in some secure manner, right? And of course, once again, this is not job for some security team. There is a privacy officers in a lot of the companies, but if you think about it, those people, they are just there to actually make sure that the privacy happened, right? But you as a software developers, you need to really start thinking about how you embed the privacy principles into your product, into your applications, into your web pages, into your code, right? The mishandling of the privacy can really destroy the whole company. Think about it, right? It erodes trust. So if you will tell the users that, hey, you can trust me to give me your credit card information because I will charge the credit card, you know, and that's what I will use it for, right? But then you will lose the data. Someone hacks you, the data were not encrypted, so now they are in a plain text and someone got hold of it and someone now do a fraudulent charges on the credit card. Your customers will not be happy, right? They will probably not trust you again when you ask for the credit card again, right? You can break laws. There are actually laws and regulations, and we will talk about some of them. There is all kind of laws and regulations about PIIs and health privacy information or data, that if you are in that business, right, if you work for a healthcare industry, for academia, for FERPA, right, you actually have to obey the laws or you can go to jail over here, right? That can really lead, at the best, the massive fines for the company or enterprise, right? At the worst, once again, you can actually be fined liable and you can go to jail, right? There are, some people that actually went to jail for because they didn't take this seriously, right? The three core privacy principles, if you think about it, right, is number one, data minimization. That's the golden rule, the number one rule, right? if you don't need the data, don't ask for it. Yeah, it's kind of the catch-22, right? Because, I mean, in the US, unfortunately, the privacy laws are kind of lax. A lot of companies, they understand that the data is actually very valuable. So they will try to grab as much data as possible, right? They sometimes don't even know why they having so much data, or what they will do with all of the data. They just it's almost like a habit, right? I will grab it now and then later I will figure out what to do with them. Now they will deploy all kind of AI systems against large data sets and ask the AI to actually make some sense of it, right? To tell me, hey, what can I do about it? How I can monetize this? How can I sell the data? Can I, entice my past customers to build to buy something in a future? All of these are now kind of coming to head over here, right? But you have to really flip that paradigm. You really have to start thinking about that, hey, if privacy is my core responsibility for my customers, right, then every piece of data that I collect and that I store, that I process, is potential liability here, right? Once again, if I don't care how minuscule it may be today, but if I will have some information that can actually identify my users and now someone else gets hold of it, I just erode the trust, right? What does it mean for my regulations and laws that I actually need to operate with? So the fundamental question is, do I need to collect the data from you? And if I don't, then why would I ask for it, right? Guess what? It's none of my business, essentially, right? If is it not really mission critical for me to have it, right? So the minimization, golden rule, hey, try to really cut down on the amount of data that you have, right? That will really make your life much easier, and it will allow you to manage it much better than if you have a huge data lakes that you don't even know what to do with, right? Second, transparency and control, right? Be honest with your customers, right? Everybody collects data. You have to collect data. Some data it's necessary to collect, right? If someone is procuring services or goods from you, then logic dictates that you need their credit card information. You need their address, right? The billing address. You need their phone number, right? Which is okay. Hey, that's part of engaging in business transactions. Everybody understands that. You probably need to know a name, a few other informations, right? But you really have to tell the users, A, what data you collecting, right? How long you will keep them and what they will actually be used for, right? And that goes with the 2 and 3 kind of, right? Hey, this is what I collect from you, right? This is what I will use it for, right? And if you don't want me to have the data, here is a way that you can follow, procedure that you can follow. So I actually delete the data, and I can anonymize them, right? Sometimes you cannot really delete it, especially if it's financial information, which is okay, right? Because there are actually ways how you can anonymize it. So you can still collect it, you can still, proof that you did your due diligence, and if IRS or any federal, state, or local agency will come, you can still show them the transactions, but you don't really have the uh, data about the customers that they seek, right? Just tell them, right? Hey, I'm collecting X for Y, now nothing else, right? And then, of course, you have to stay within that statement, right? You cannot just say, hey, I will collect this to process your information for fulfilling, my order to you, and then turn around and sell it to someone else and say, hey, guess what? They just bought something from me. I think that they will buy something from you too. So if you will pay me $5, I will give you the contact information so you can actually hit them, right? So transparency and control. And then of course the last one kind of roll with that, it's the purpose limitations, right? what did I tell you I will collect the data for, right? And do I actually use it for that purpose and that purpose only? You know, if I am telling you that, hey, I will run the credit card, charge the credit card. Once I get the payment from that credit card that you just used to pay me for the goods or services, right? And then I told you that I will, delete it right afterwards because I don't really need your credit card number, right? Did I actually do it, right? Or am I now selling it to someone else? And that's a lot of companies. That's how they make their money, right? If you think about it, if you look on a social media, right? Facebook is a perfect example, Meta, whatever you want to call them nowadays, right? They don't really make money. They don't sell goods or services at all, right? They sell a little bit to advertisers, of course, so you can see the advertising over there. But majority of their income comes from the user's data, right? Every single time when you click on something, when you like something, when you post something, they will use the data and they try to monetize it by selling it to companies, right? Companies will come and says, hey, give me all the information about, you know, people who had a new baby, right? That they post something about new baby. Either they have new baby or they went to the baby shower, so the baby is coming, or whatnot, right? And Meta or Facebook will actually run the algorithm and it will says, hey, guess what? There is 100 million people in the past week that actually, had something to do with the post about baby. Here are their information, so you can start advertising them, right? Now, they didn't really disclose it, right? That they will sell it, right? They didn't say that, hey, this is the purpose that we collect the data. They didn't put any limitations because that's their business model. Let's be frank over here, right? You really cannot afford this anymore, right? There is a more and more privacy laws, regulations, and those privacy harms, and we will talk about privacy harms in a little bit here, they have a real world consequences now, right? So, if you collect the data, tell the user why you collecting it, right? And what will happen once you have it, right? How long you will keep it, for what purpose, how do you get rid of the data, right? When you no longer need it for that stated purpose here. So that's kind of the three core privacy principles here. The whole uh, privacy paradigm now is kind of wrapped in what we call the privacy by design, right? And I talked about it at the very beginning. It's no longer good enough if you will just develop something that works and then you sprinkle some privacy and security on top, right? Really, nowadays, everything you do, every piece of code that you are working on needs to start with the privacy and security as a core requirement. And we call it privacy by design, right? It's like designing the house. It's easy to add locks to the blueprint. It's much harder to and less secure to try and board up the windows after the house is already built, right? So think about it. If I will just think about it from the get-go, I can say, hey, guess what? I know that the people can attack me in these 2 points, right? I can protect these 2 points, versus just developing something and after the fact finding that you have a 15 different attack vectors, right? The directions that people can actually gain access and abuse, and now try to actually find a workarounds, right, or controls to close those 15 openings, if you will, right? The key principles of the privacy by design, and there is 7 of them, right? But I really like the 3 here, and you can actually read the whole 7 key principles of privacy by design. But I really like number 1, and that's kind of the once again golden rule to me, right? Be proactive, not reactive, and we just talk about it, right? Don't wait for the users to actually tell you that, hey, something happened, you have a flaws, I just lost my data, right? It's usually too late. The cleanup is always more costly than developing the privacy, the security from the get-go, from the scratch, right? So anticipate, run some risk analysis, anticipate the risk, right? And then actually devise and implement the control as you are planning the applications or the code, right? Then, of course, privacy as a default settings, right? So, the default setting should be the most private, right? There is a two-way of thinking about it. You can make everything wide open, right? So, and then you essentially putting the focus squarely on the users to go in and make it more secure, right? Less available, more secure. It's the CIA triangle essentially that we talked about at the very beginning. Hey, guess what? Everything is available, nothing's really secure, right? Because it's the inverse relationship, remember, right? Or you can say, hey, everything is essentially closed, right? So everything is very secure, but it's not as available. It's not as convenient, really. Convenience is better than availability, but unfortunately, we are talking about CIA triangle, so there is no convenience in there. But if you think about convenience equals availability in this scenario, right? So it's very inconvenient, very secure, right? You really have to find that middle ground, right? You want to be convenient to the point without jeopardizing the security of your application, and you should always err on the side of security, right? Meaning that, hey, if I have 15 different ways to get in that, people can actually log in and see the data and do whatnot, then by default, you should really try to close every single one of them. And if the users want to open any of those 15, let them do it, right? Let them, let's just tell them that, hey, if you need to do this, and that, that's okay. But, you have to understand that there are security, privacy implications of every of those changes. But by default, when we are starting, when you uh, set up and configure your my applications, then guess what? All of these things are essentially closed, right? I'm giving you, a house that is locked, the windows are down and the security system is up and running, right? If you want to open the door, open the window, disable the security system, that's up to you. But, you got the house that is essentially secure versus, hey, here's the house, everything is open. So, you can come in, do whatever you want, and then if you want to close your window, if you want to lock your door, if you want to set up your alarm, you need to do it to yourself, right? And then, of course, full functionality, right? So never choose between features and privacy. Good design, if you really put the privacy by design as a central piece of your development, you should never get to the point when you need to choose, right, between privacy and features. Because guess what? All the features will work with the privacy that is already built into them, right? If is it something that you don't want, right? The feature that you don't want, you are not concerned about the privacy, right? If there is a privacy consideration, it's been already addressed during the planning phase. So you essentially have this, all-encompassing design that now, if you're talking that, hey, I have a functionality or feature A here, right? It's already by design secure and it has the privacy already built in, right? And that really gives you win-win, because once again, you are not doing it after the fact. It's already built in. It's already working as intended because you spent the time during the development phase to actually get it right here, right? Uh, we kind of talk about the hashing versus the encryption, right? There is a one great email, once again, that you can go through that talks about the hashing as a one-way trapdoor function that, you are just creating the fingerprint of some input, right? You cannot decrypt it, of course, for the encryptions. Then you need to be able to encrypt and decrypt back and forth, right? They are kind of, very similar about how they work, right? They are running through some mathematical computations that actually create something. The main difference is that encryption, you have to be able to decrypt it, right? So you have to be able to get back to the original plain text. With the hashing, the whole point is that you shouldn't be able to get the original plain text, right? The attack then is fundamentally different. For the hashing, you are looking for what we call collisions, which means that you found essentially the hash and uh, you can equal the hash with some predetermined input, right? That's how you essentially get the password. If the password is password 1234, right? If you run it through the hashing algorithm, it will give you some hash, and then you just will have a list of hashes. And if you run it through, you will get the same hash. And because now you have the hash, and you know that the hash actually means password 1234, that's what you got, right? You didn't decrypt it, you found the hash that actually matches. For the encryption, fundamentally different, right? It's the XOR that we just talked about with the email, right? You put the key over there, you XOR, so you actually switch, or transpose, if you will, the plain text into the ciphertext by inputting the key below it, right? And of course, because you know the key, then if you will use the key, you can go back and you can decode it just like you did the encoding, right? So you can go back and forth. You can actually save it as a, encrypted text somewhere, right? And come back later and actually decrypt it to the original input that exists for that. We talk about the harms, right? So when people talk about privacy, a lot of the times it's all abstract. There is no uh, physical equivalent of that, I will say. What does it really mean that someone will steal your credit card numbers, right? What does it really mean that someone steals your social security or your private health information? How does it translate to the real world around you, right? Some examples that I could find over here, the Strava heat map, in 2017, that was actually a fitness app, right? That create kind of a heat map that should show how the users are actually using the app and, what the exercising patterns are. It was a kind of a cool visualization of, uh, what the healthcare technology can do for you, right? So they will show where people run, how much you run and what the GPS coordinates are, and when you work out, what was your heart rate and resting periods between the sets in a gym and all of that, right? The problem, of course, was that, as people were wearing these devices in a secret locations or, off the grid locations, if you will, such a military bases, once you put it on that GPS location on that grid, right? The adversaries get pretty good idea about the layout of those facilities, right? They now found out, hey, how the people patrolling, right, uh, protecting the perimeter of the bases are, where they go for a meetings, right? Where is the gym, where they sleep, because all the informations were actually there with the information about what they actually did and what was their purpose over there, right? So it creates this huge problem for the DoD three-letter agencies, but even for our regular people, right? Because now you can actually follow someone, through their runs, right? You can actually go and you can see where they run every night, so it creates all kind of security risks for the users, right? Great idea, but once again, in a real world, it creates enormous problems, right? So for you as a developer, what can you do about it? Once again, opt in, right? Don't enable the functionality from the box, right? When people get it, when people buy it and put the tracker on their wrist or install the app on their phone, you have to ask them what and how they actually want to do with the data, right? In any given time. Guess what? I can collect this. Do you want it to share it, right? Should I share it with everybody else? Do you want to track it with your family, with your friends, with everybody, be part of the community, right? Don't just assume that they will all want to share it. And if they don't, they will go into the settings and they will disable the functionality themselves, right? A lot of them, they don't even know that the functionality is there, right? You have to be proactive. You have to do what we call opt-in, meaning that, hey, everything is essentially disabled. If you want to use something, you have to enable it yourself. You have to explicitly tell the app that, hey, this is what I want to do over here, right? You can do something like data fuzzing over here, right? So if the sample is fairly small, if let's say that there is a 20 students in the classroom, right? I don't even need, high computing power to probably figure out what data belongs to what students. Yeah. So you can just inject, right, some data to distort it. You can either inject it, you can put it as a part of the bigger sample, but you can distort it to actually, kind of blur it with more data and take the precision away from someone to actually figure it out, right? And then of course the aggregation and anonymization, and that goes kind of with the fuzzing here, that you really want to if you have small samples, you want to make them bigger. You want to anonymize the data as much as possible, so you don't know what the who the users are and why they do what they do, right? uh, the Equifax breach, very famous, right? In 2017, 147 million Americans from Equifax, that's the company that does your uh, uh, financial scores, right? So the data, of course, includes everything, right? Because for them to actually run the credit scores that the banks are using, they need to know your social security numbers, birth dates, addresses, employment history. All of that comes into it, right? Your payment history for all your accounts, loans, credit cards, all of that was actually lost over here, right? This was really the worst case scenario, right, for identity theft, because they, in one big swoop, they got every piece of information that they needed to actually steal people's identities, right? Usually you will get a social security, and then you need to find the addresses, and you need to find the credit cards, or the account numbers for that. Then you need to find the mother's maiden names and all of that. I mean, because of the aggregation of the data in Equifax, it was literally one of the worst that ever happened over here, right? What happened over there is that there was a patch that wasn't installed, so it was technical solution, right? Once again, it was abstract, of course. What does it mean that my credit score information has been stolen, right? I mean, in a real physical world, what does it really mean? Not much, right? So the harm is hard to define, right? How should I actually approach it? What should be the compensation for something like that? I mean, there's a physical harm that goes with the privacy breaches here, right? The prevention, of course, patch the dependencies, right? If you are using someone else's code, if you figure out that your code is unsecure, you really need to fix it ASAP. You need to download the patches, install them, right? Deploy something like a network segmentation. So hey, if you have a sensitive data, social security numbers, PIIs, PHIs, it really should be on its separate network that is more protected than the rest of them, right? And then, of course, manage the certificate, right? So you have security certifications for your apps, for your web pages, right? Manage it so the users actually know that is correct and that is trustworthy, right? Once again, if you don't have that TLS, if you don't have the little lock on top, then by default it's unsecure, and it probably shouldn't be used at all, right? Reputational harm, so Ashley Madison kind of, that was the breach that actually exposed the online, and I will call it dating, right? Here, let's call it dating, right? So, a lot of people, they went on the dating side, right? They were married, so it was affairs, right? They don't really want the data to be actually publicly available for obvious reasons. We will leave the morality of that out of this discussion for now, right? Now, the harm was not financial. They actually didn't go after the credit card numbers for the people who actually pay for the service, and they pay for the service, right? I don't know what the service costs, but they paid monthly fee, so they were actually credit card information number, but that's not what the attackers went after. The attackers essentially went after the database because they want to know who is having affairs, right? So they can blackmail them, so they can get more money, right? They can get favors from these people. They can quote unquote ruin their life if they choose to do so, right? So it was all about their reputation, destroy their reputations if they will not, play ball with them, so to speak, over here, right? How it could be prevented? Strong hashing. We just talked about it, right? How do you prevent the data over here? You hash them, right? You encrypt the data that you need to use, that you need to encrypt, decrypt. You hash the data that you don't need to decrypt. You just need them for verification purposes, right? Actually delete the data. There was tons of users in the data set that deleted their accounts on Mashley Edison like years before, right? But nobody really went in and cleaned. There was no procedure for the people to actually clean it. So there were people who got caught in that mess, because they had account over there, then they, stop paying, right? Cancel the subscription to the Ashley Medicine. Yet, their information came back 3 years later, right? Because I mean, at some point in the past they had it, so multiple lapses that brought real big pain. The company actually ceased to exist. They went through the bankruptcy because there was a big judgment against them. It kind of got lost into that whole, once again, morality of that, that some people, they almost felt like the customers deserve it because what they did, that they had affairs. But the fact remains that this was a preventable privacy breach that has a real world implications for the people, right? And then the last one is like a chilling effect, right? The we are living in increasingly surveillance society, if you will, right? So if your customers feels like your applications, your code are essentially collecting the information for no apparent reason, just to quote unquote spy on them, right? So you can use the data later, and they don't even know what for, and then they don't know how they will be used, right? That's a big concern right now, especially with the AI. Now the kind of the paradigm shifts a little bit, about uh, what who is actually make the decisions about what's right and what's wrong, right? As the society evolves, hey, it's not about that the data may be harmful today, but if the environment changes, they may be harmful to you or your customers tomorrow, right? So what do you actually do about that? And for that, of course, as a developers, the data minimization, right? Just don't collect it. If you don't need it, then who cares? You don't need it. That's the bottom line, right? Limit the purpose, be very specific about why you collect it and use it only for the purpose that you stated over there, right? And then the transparency, hey, who is actually asking for the data that I have now? How do you share it, right? What will happen if federal government agency will ask for the data, right? How do you actually approach that request? Are you just giving it to them? No questions asked, quote unquote, right? Are you going to question it? Are there some boundaries that you will not cross, right? All of that instills the confidence in your customers that you actually have their best interest in heart, right? You need to be aware that there are actually now lot of regulations and laws that exist for that actually protect the privacy of your customers, right? Probably the most famous, GDPR, General Data Protection Regulations from the UE, uh, huge penalties, right? If you actually don't follow it. Uh, it's not just for the European Union, it's actually for every European Union citizen. So whoever has a passport from one of the 27 European countries, it's automatically covered by that law, even if they live in the US or anywhere else on the planet, right? Huge fines over there. Uh, the thing that really makes it powerful is that the users can now ask the companies to be forgotten, which means that they can actually ask the company to be deleted from their data sets, right? And the companies, they have 72 hours to actually both delete it and let the customer that the deletion took place, right? Once again, if it's a financial institution or something that for regulatory purposes, the company needs to hold onto the data, they actually can uh, anonymize the data, right? So they don't have to delete them. They just need to show that they protect them with anonymization, replacing the data for something else. But, you have 72 hours, right? You have to be aware of that. CCPA, CPRA, so the California Customer Privacy Act, kind of modeled after the GDPR, right? So the GDPR was the first, of course. Now a lot of the US companies, right, they have a European customers, so they understand that they need to follow the GDPR to some uh, degree, right? Maybe not as strict, but to some degree. So they are actually now kind of following in the footsteps of the GDPR, if you will, right? Right now, the CCPA, of course, because it's a state law, and it's really for the California residents over there, right? Uh, the whole point of CCPA is actually to give the users, the customers, if you will, the uh, total control over their data, right? So as you are collecting the data as a developer for the company, you know, the assumption is that the user, that the customer still owns it. It's not your data. You are just a custodian that actually takes care of them, of the data for now, but it's still the decision of the user about what will happen and how you can use the data, right? And then, something like COPPA, the Children Online Privacy Protection Act, about 20 year old now, right? It really protects anybody under 13, right? Uh, it's a law that was specifically designed and passed to protect the kids online, right, from collecting uh, any and all information really about them that that the companies can use to solicit it, sales and all of that, right? So it's very strict about what you can actually collect from I would call them minors, right? So anybody under 13. Yeah. Now there is a big push to actually expand it for the social networks, and what will happen with that, nobody knows. There is a big lobby, of course, the big tech companies, they want to they pushed against that, right? But most applications, a lot of the big tech companies, right? They are very aware of the Children Online Privacy Protection Acts, because they understand that it's a big fines, and once again, there are actually jail times if you willfully disregard it as a law. Of course, there are some pretty severe consequences to it. Right. You can do some scenarios over here. The ethics debate. I will take at least 15 minutes. And the kind of work on one of those two scenarios. I really like them. Right. A lot of the privacy uh, conundrums, if you will, or dilemmas. Right. They are really ethical dilemmas. Because in a lot of instances, you as a software developer, you have a great idea how you can help, right, your customers to achieve something, right? And you are really working, that desire or the need to help them against the backdrop of what is actually ethical to do, right, in your quest, and how someone can abuse the technology that you are developing, right? Because at the end of the day, your code is a tool like anything else, right? It's just like a knife. In knife, I can cut up bread and feed my children, right? I can also stab someone to death, right? It's just a tool. It's all about the application, how you use it. Technology, in many ways, is the same thing, right? It's a tool. You can use it to create an enormous good in society, right? It can also create enormous bad depending on what the consequences of these decisions are. Yeah? And you really need to navigate that moral dilemma, the ethical dilemma, if you will, as you are trying to figure out what your application actually does, right? How do you approach it? What will be some of the boundaries that you want to set around it so you minimize the bad and magnify to good, if you will, right? So, both of them, I kind of like to find friends, right? I mean, once again, a lot of people, they kind of want that. They want to find the friends. It's a great feature, right, of the applications that that you may think about, because that's how you grow your customer base, right? So it's good for you. The users, they generally like it because they can find friends, right? But I mean, it has some unintended consequences for sure, right? So what is the liability side of that? And the helpful location log, the same thing, essentially, once again, you are collecting information that can help tremendously to the business, right? But what are the privacy harms that you are introducing with the decision, and how would you, right? Because this is not one size fits all, this is really opening for the discussion, it's what your personal beliefs are, right? What do you think is good for the society, right? For your users, all of those ethical considerations, if you will, kind of come together, and you need to make the decision, right, as a software developer about, hey, what is and isn't ethical? What is the line that I don't want to cross as I'm making all of these decisions here? So if we will take 10, 15 minutes, maybe just to discuss it in a small groups, that's fantastic exercise. I think I'm a big believer in that. And then, of course, the privacy policy, we talk about it. It should be part of your uh, development, right? You should always tell the users what they can expect, right? What are their rights to the data here. There is a lot of legalese, right? A lot of lawyers. If you sign up for anything in your life, you know that nobody reads it, right? That's rule number one, because it's usually like 20-page long, and there are words that half of the population cannot even pronounce, right? Your job as a good software developer, a good digital citizens, is to make it as uh, clear, I would say, right, as you possibly can for majority of the population. It's easy. Let me tell you, it's easy. If you want to trick your users, it's incredibly easy just to write, once again, 20-page privacy policy that will essentially somewhere in the middle state that you can do whatever you want with the data. You are not liable for anything that it will happen with the data. And you are essentially showing the proverbial finger to your customers, right? Nobody will read it. There is 1 in a million potential customer who will actually probably read it and not agree with that. 99.99999% of your customers will just click OK and will move on, right? And guess what? It will actually give you a cover, believe it or not, because you can always go back to that policy and you can tell that, hey, they agreed to it. I told them right here what I will do with it. They agreed to it. So I am essentially, that doesn't make it right. So, be a good citizen, right? Make it palatable. Make it so users can actually understand without hiring some $500 per hour lawyer who will actually translate it into plain English. Good example over here. We may from time to time share aggregate non-personally identifiable or de-identified information with our partners, adversaries, or other third parties for research, marketing, or purpose. What does it really mean? Right? Well, it means we don't share the data with anyone. Well, no, not really. I mean, they are saying clearly here that we may from time to time share, so that doesn't mean that they don't share, right? We only share your data if you win a contest, right? I don't know what that means really, right? It really means that, hey, we will sell the anonymized data to advertisers, right? Or anybody else who will ask for it for any and all reasons. That's what it means here, right? We may from time to time. That means that, hey, anytime we decide, right, we will share anonymized, right, non-personal, de-identified information with partners, advertisers, or anybody else. That's what it means, right? So you can actually go through it, and that's the legalese that you really want to avoid. That's something that I'm a big believer that if you want to be that you need to be really, not if you want to, but you need to be upfront with the with your customers about your intention, what you actually want to do, right, with the data. Yeah. Little quiz over here that you can go through, a few questions, right, that I just put over here kind of to drive home some of the concepts here, right? You reach the end of the lesson over here. Congratulations. I hope that you found it interesting, and I hope that it will help you as you are developing your code here. I will ask you to read this, right? The developer's pledge for your own sake, right? I will not trust the user's input. I will hash all the passwords. I will respect the user's privacy and collect only what I need. I will build apps that I will trust with my own data, right? This is kind of the golden rule, right? Do others as you would like to be treated, right? So if you wouldn't put your own data into application, that's pretty good indications that you probably need to change your approach here, right? But if you think about, these are the three main things that we talk about, right? Never trust, always validate the user input, right? Hash all the passwords, right? And make sure that you encrypt the data if you need to store, process, or transmit the data from the users, right? And as far as privacy goes, respect the user privacy and collect only the necessary information, right? Minimize the collection of the data, right? Trust me, this is not extra work, right? This is really what makes you good software developer, good digital citizen, and IT professional, right? Because we talk about it, this is not about some privacy council. This is not about the cybersecurity team. This is responsibility of everybody who works on IT projects, right? And that includes you as a software developer here. The last thing that I have for you is just the simple links to some of the interactives, the emails that are pertinent. There is lesson over here. You can see that there is the interactive for the CIA triad, right? The SQL and the cross-site scripting demos that you can go through if you want to know a little more about how people can actually exploit the code, right? And then, of course, hashing versus the encryption, kind of the two different approaches. One, to create the fingerprint of the data, that cannot be recreated. The second one, of course, encryption, how the encryption works, right? What will be the XOR that will actually allow the modern algorithms to encrypt something so people cannot see it without the proper key. And then, of course, if they have the proper key, how they can recreate, right, decrypt the information into readable form. And then if you want to know a little more about the cybersecurity in general, this is not just for the secure coding. There is the OWASP top 10, right? So every year the OWASP actually puts the top 10 vulnerabilities for web pages and applications they collected. So that's the link for the web page that you can actually go and see, over years how the top 10 actually evolves, what are the latest trends. And what the attackers are looking for in the code and application. So hopefully you can start thinking about how to close some of those vulnerabilities, or not even close them, really just avoid creating them as you are thinking about and start building your application over here. All right. Once again, hope that you find it interesting. I really enjoy teaching it. Wish that I can do that and have some discussion with you about some of these concepts. But if you have something, then please let me know. The link for the interactive is right here. You can enjoy it, have fun with that. The links to the emails are on the last page. Right? Thank you guys. Looking forward to see what applications you actually created. Mahalo.